Hi, Dan Selman here. Just going to give you a quick demo of using LLM chat to interact with a knowledge graph. So I've loaded about 4,000 movies from IMDb into a knowledge graph, along with the people associated with those movies. And I'm just going to use this chat interface to start asking some questions about the data. Let's start simple. How many movies are in the database? So in the light grey, we see the debug output that's going to help explain how the system is answering that question. And we can see that a cipher query was generated from the natural language query that I just expressed in the prompt. So it's a simple match over the movies, and we're going to return the count of movies. And then the response is converted back into text by the LLM. So there are 4,598 movies in the database. So it clearly used the knowledge graph to answer this question. And it was the LLM itself that determined that the knowledge graph was the right tool to use to help answer this question. So now let's try something a little more involved. So which year post 2000 had the most released movies? Again, the LLM decided to use the knowledge graph tool to answer this question, and we see the cipher query that was generated. So it's a match again over movies, but in this case we've added a where condition where the start year is over 2000. We're counting the movies, we're ordering them in descending order, and we're taking the top one. And the response is that it was 2008 that had the most movies. 179 movies were released in 2008 based on the data in the knowledge graph. Pretty cool. So now let's ask a question about a specific movie. What people are related to the movie June released in 2001? So it claims that there was no movie titled June released in 2001. So let's try again. What movies in the database are titled June? So we see the cipher that's generated. It's a match over movies with the title June, and it finds 3 movies. June released in 1984, and then we've got June 2021 twice. The one of these is probably a feature or something. So that could be what threw off the first query. So let's say give me all the details for the movie with this identifier. So this is basically displaying the properties of the node in the graph. The title is June, the runtime is 155 minutes, the average rating is 8, etc. So let's try again. What people are related to the movie June with ID? So now it's generated a cipher query. It's matching over movies with that identifier, and then it's finding people that are related to that movie. And it's pulled back 5 people: Zendaya, Denis Villeneuve, Oscar Isaac, Timothée Chalamet, and Rebecca Ferguson. So let's ask a follow-up question perhaps. What other movies has Timothée Chalamet appeared in? Again, we see the cipher query that's generated. So now it's It's matching on a person with the name Timothée Chalamet, and it's finding related movies. And the ones in the database that came back are these 12. And you can kind of tell that this response was generated using the data from the knowledge graph, but kind of enhanced with the general world knowledge that the LLM has. So in addition to these films, he has made numerous television appearances, etc., etc. So perhaps now let's ask a more challenging question. Do you have details for the person Josh Brolin in the database? So we do have details about Josh Brolin. So let's see if we can find a path. What is the shortest path from Josh Brolin to Timothée Chalamet? So it's going to generate a cipher query again, and it's going to try and find a shortest path between these two people using this related to relationship. And it seems like these people are not connected. So let's do that again, but just as a test. Let's pick somebody we know is related. Let's pick Rebecca Ferguson. So the shortest path from Josh Brolin to Rebecca Ferguson is through their appearance in the movie June. Josh Brolin appeared in June. Rebecca Ferguson also appeared in June. So they're directly connected through their work on the same movie. So that's pretty interesting. So far we've just been essentially generating cipher queries from natural language. These are very structured queries. Now I'm going to push the LLM to start to use some of the unstructured text content that we have in the knowledge graph. So for this demo, that's plot summaries of all the movies. So let's ask this question like, has Rebecca Ferguson appeared in a movie where the theme of the movie include natural disasters? So when we look at this debug output, it's slightly different, because what we're doing is we're saying we would like to query the movie summary index, and we're looking for a vector embedding that's close to the string natural disasters. So we're going to be looking at all of the plot summaries and comparing the vector embeddings for each plot summary with a vector embedding for the string natural disasters. And then we filter that let me see where the filter is. Yeah, we filter that by the name Rebecca Ferguson, and we're looking for a movie that is related to that. So it appears that none of the movies in the database with plot summaries are close to the theme of natural disasters. So let's probe that a bit more. What are the themes of the movies that Rebecca Ferguson has appeared in? So this is pretty interesting. We see a failure here, which is kind of nice. This is a real demo. I'm not cheating and using pre-canned queries that I know are going to work. So let me walk you through what happened here. So first of all, we said, well, find find movies in a genre related to a person, and then we attempted to query the nodes using this person name index, where the vector embedding was the string Rebecca Ferguson. And the problem with that is person name is not something that we index using vector embeddings. So the query failed because there is no such index called person name. And then after that failure was returned to the LLM sort of retried, it kind of backtracked, and it said, well, if I can't run that query, then let me run a simpler query, which is simply find all of the genres of the films that Rebecca Ferguson is related to. And then it rendered those as a list. So now we're looking at this structured genre information associated with all of Rebecca Ferguson's movies, and it even used a distinct there, to make sure that we didn't duplicate genres. So a pretty nice sort of course it was an error, that wasn't my intention to cause an error, but it's very interesting to see it self-heal, self-correct in that way, and it's all orchestrated by the LLM via a system of LLM tools. So let's try. What are the plot summaries for Rebecca Ferguson movies with the genre action? Let's see how many we have. Not too many, I hope. So we see the cipher that's generated. So yeah, that's interesting. So the movies exist. They've been tagged with a genre, but we don't have plot summaries for them. But their summaries are not provided. So let's ask a simpler question. What are the plot summaries for? What are three plot summaries for the most highly rated for Rebecca Ferguson movies? See how we deal with that. So we see the cipher that's generated. So it looks pretty interesting. We're matching by Rebecca Ferguson, finding related movies, ordering by average rating. So we're taking the three most highly rated movies starring or related to Rebecca Ferguson, and unfortunately none of those seem to have plot summaries. So let's take out the most highly rated. So again, we got an error, probably the same thing. Yes, it's trying to use this person name index, which makes me think I should index person names. That failed. So then it falls back to this query, which is find Rebecca Ferguson movies and then query the movie summary. And it queries for give me 3 plot summaries for movies starring Rebecca Ferguson. Not a great query, frankly. But it does find 3. And probably those the similarity of those plot summaries is not that high to the string 3 plot summaries for movies starring Rebecca Ferguson, but it works because even though the similarity is not that high, there are 3 of them, and it's able to display them. Now let's follow up with a question that the LLM probably doesn't need to use the tool to answer. So combine these 3 plot summaries into one plot in the style of Spike Lee and name the movie. So here we go. The movie is titled Betrayal Bound. The plot summary is: in the heart of Paris, the city of light and shadow, Tess Parker, a sharp-witted therapist, Jo Beth Williams, finds herself entwined in a web of deception, danger and betrayal. Blah, 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 blah. Hard to say. So Betrayal Bound captures the essence of Spike Lee's dynamic narrative style with its intricate character studies, intense dialogues, and a pulsating backdrop of betrayal and redemption amidst the sleek, dangerous underbelly of Paris. So you can see no cipher generation. Basically, the LLM used its conversational context to answer this query, or to carry out this command. And this is a good use case for the creativity or the hallucination of an LLM. It kind of has free reign at this point to probabilistically generate some text that meets our request. So I think I'll stop there. I hope this gave you a sense for the power and maybe some of the limitations of this approach. There's obviously much more work to be done, but I'm very excited by this combination of structured query, unstructured query, and LLM orchestration. Thank you very much.